Hess's law problems really aren't that difficult. You just need to know what you're doing, what you're trying to do. Usually you're given an equation, like some overall equation. You're given some smaller heats of formation, and you have to try and make that given equation. So let's look at an example. Calculate delta H F naught of acetylene we have 2 carbons, solid graphite, plus H2 gas gets us to C2H2 gas. You're given. I'm going to write physical states on here. Physical states do matter when you're considering heats of formation, but we can be kind of lazy and leave them off. But just know that sometimes they do matter. Solid graphite plus O2 gas gets us to CO2 gas. Delta H reaction is equal to negative 393.5 kilojoules per mole. H2 gas plus 1/2 O2 gas gets us to H2O liquid. Delta H naught of reaction, negative 285.8 kilojoules per mole. And we have 2 C2H2 gas plus 5 O2 gas gets us to 4 CO2 gas plus 2 H2O liquid. Delta H reaction, negative 2,598.8 kilojoules per mole. Okay, looks scary. It's not as scary as it looks, I promise you. Okay, so what are we trying to do? We're trying to manipulate these given equations to give us this resulting equation. So what I suggest is to find any compounds that only appear once in all of these equations and make sure they're on the right side. If they're not on the right side, we have to flip them. Okay? What compound do we want to focus in on first? Yeah. Okay, so put H2 on the opposite side. I would not touch this one yet. The reason is oxygen appears in a handful of spots, and that scares me. Okay. Any other compounds? Yeah. I'm sorry, can you repeat that? Oh, the bottom one? Yeah, we need to flip it so it appears on the other. Why do you want to flip it?
Because that's the one where it only appears once.
Right, so this guy only appears once. So what we're going to do, we're going to flip this equation. I wish I had another board. If I write down here, can people in the back see or no? All right, we're going to try to write up here. So what we're going to do, we're going to flip this equation. Or actually, everybody has this written down, right? The kilojoules are written down. So what I'm going to do, I'm going to erase this part here. That okay? All right. So this equation's got to get flipped. So we're going to flip it around. We get 4 CO, actually we'll write it down here. We got 4 CO2 plus 2 H2O gets us to 2 C2H6 plus 5 O2. Okay. What happens to delta H when we do that? Yeah, it becomes positive. So what's the value of it? Yeah, 2,598.8 kilojoules per mole. Okay, saw a hand up? Yeah. Yes, it is. Sorry. Stuck in another plane of existence right now. All right. Any other? I saw one more hand go up. Okay. Yep, I got you. Now, what is the problem with this? Does the stoichiometric coefficient match what's in our given equation? No. So what do you suggest we do to make it match? Divide by what? By what? How many of these do we want? 1. Right now we have 2 of them. What would you divide this through to make 1? 2. If I do it to this guy, I have to do it to the other ones, right? Okay, 4 divided by 2, what's that become? 2 divided by 2. We already did that one. And 5 halves will stay the same. Now, if I divide it by 2, by the stoichiometric coefficients, what do I have to do to my delta H? You also have to divide it by 2. So this also gets divided by 2. Okay. That's all we can really do with this equation. What do you suggest we do next? Or what compound do you want to focus on? It only appears once in these equations. I would look at solid carbon. Okay, there's only one spot where solid carbon appears. Which of these equations? First one. Okay, so let's write that first one out. Do we need to flip it? No, it's the correct direction. It's on the same side. So we got carbon plus O2 goes to CO2. What was delta H for this reaction? 300, what was it? 95.5 kilojoules per mole. Okay, first question. We're fine with our sign, right? We didn't flip it. We don't need to change a negative to a positive. Is there anything else we need to do to this equation to make it look closer to that given? Yeah, we got to multiply that by 2. So you multiply, 2, 2, 2. What happens to delta H then? Yeah, we got to multiply by 2. Okay, as we're looking at this, can anything cancel out? Does it appear on both the left and the right side of these equations? Oxygen, yep, there are 2 oxygens here, right? So we can cross those out. What does this fraction become then? Not 3. Yep, that becomes 1/2. Can we cancel anything else out? Yep, there are 2 CO2s here. How many CO2s are here? So they're gone. Okay. Last step, what are we missing? Out of this given equation, what don't we have yet? Hydrogen gas. Okay, which of the given equations does hydrogen gas appear? Second one. I wanted to stay away from this one because oxygen was around everywhere, but we don't have any other choice. So do I have to flip that one? Change its direction? Nope, I don't have to worry about that. So we get H2 plus 1/2 O2 gets us a water. What was delta H for this reaction? Negative, what was it? 285, no decimal. 0.8 kilojoules per mole. Okay, do I have to multiply it by anything? I saw a head shake no. How do I know I don't have to multiply this by anything? Yeah. Yeah, we got a 1 here, we got a 1 here, so we're good to go. Is there anything that will cancel out? Yep, the half O2, that's going away, that's going away. Somebody said the water, that's correct too. That goes, and that goes. We didn't have to multiply this delta H by any stoichiometric coefficient, right? Because we're just fine with the way it is. Now, if we sum up everything, what's the overall equation we're going to get? What was that? Yeah, the original. We should get this guy. Now, how do we figure out delta H for this? Like overall reaction. Yeah. Yeah, add up these values and keep in mind where you're dividing, where you're multiplying. If you do that, delta H of this reaction should be 226.6 kilojoules per mole. Okay? It is really not that hard. It's just manipulating equations around. It's a puzzle. It's nothing more than a puzzle.